All right, so this is Unit 4C, which is, there's multiple parts to it, but 4C is all about solving quadratics, and we're going to solve in different ways. So the first way is by the quadratic formula. So the first thing you see here is, that's called the quadratic equation, which we've studied. Different characteristics of a quadratic equation throughout the year. The next thing we see is called the quadratic formula. And the formula solves. This is used to solve quadratics. Quadratic equations, I guess I should say. Sorry for the pause. And there's going to be two different solutions. You get two solutions from here. Then quadratic, the biggest exponent is 2, so we should get two solutions. So most of them have two solutions unless it's a double. So we're going to jump right into it. So the very first thing we need to do is make sure that it's all the terms are on one side of the equation and it's equal to 0. So we're going to look down at our first example here. And we have 11x squared equals a negative 12x minus 7. So I would say the first thing, try to keep the a positive. You don't have to, but you might get some things a little bit more confused. Well, right here is the a, and it's already positive. So that means it's a little more work, but I'm going to actually add the 12x to the left side and add the 7 also. And I know it's going to be weird, but I'm going to do this in a little bit. So I got biggest exponent first, so 11x squared, then 12x plus 7. You might think, I don't see an exponent with a 12x, so how does that go in front of the 7? Well, technically it's x to the first power, and it's 7x to the 0 power. Anything to the 0 power is 1. 7 times 1 is 7. So now we have our A, B, and C. A is 11, B is 12, C is 7. Let's plug that into the quadratic formula. So it's x equals opposite of B. B is 12, so negative 12. Plus or minus, so we get two solutions from that. We're going to get 2. B squared, put it in parentheses, 12 squared. I never do any kind of computation. I just substitute everything in and then kind of gauge what I have here. 4 times A times C. Make sure that square root goes over the top of everything, and it's everything to the right of the equal sign is divided by 2 times A. All right. Now the steps I'm taking here to simplify don't have to be the ones you take, but the way I work it out, it's the exact same process every single time, no matter what you encounter underneath the radical. So the first thing all I do is I square, so b squared, so 12 squared is 144. I do the negative 4 times 11 times 7. Now I can't do that off the top of my head. It's 44 times 7. 44 times 7. 308. So that's a negative 308. I do 2 times 11 is 22. So that's all I do on my first step. Second step really seems like it's meaningless, but it's actually very meaningful. All I do is 144 minus 308. A lot of times in math, it's all about just getting to the next step, and then we can decide what to do. So all I did here was I'm looking at underneath the square root and simplifying it. So a square root is a negative 164. So now we need to take that and we need to simplify. So we need to simplify the square root. So on a little side note, let's simplify. So the negative comes out as an I. And 164 is 82 and 2. 41 and 2. And 41 does not divide by anything. So that is a prime number by itself. So we have a pair of 2's. So this is end up going to be square root of 164 is 2. There was the I there. Square root of 41. So now, I know I've totally ran out of room, but I'll bring this down. We have x equals a negative 12 plus or minus. I'm going to replace the square root. Everything on the square root, I'm going to replace it with 2i square root of 41, all divided by 22. Now, this is really close to the final answer, but there's actually one last thing we can do. You look at each term, and you're looking at the coefficients. So in particular, you're looking at negative 12, 2, and 22. Can you divide all of those by the same number? Well, sure can. You can divide them all by 2. So negative 6, 1, and 11. So you have negative 6 plus 1 times I is I, square root of 41. And you have negative 6 minus I, square root of 41. So there's the plus and the minus. You can write them together. I just wanted to write them separate so you can see that there are two actual solutions there. They're both imaginary. So if you graphed it, they would not cross the x-axis, and that's all right. All right, moving on to the second problem here. Yeah, I'm going to write it on the left here. So 5x squared minus 10x. Well, let's minus, the a is positive already, so let's subtract 15. No like terms, so we have our a is 5, b is negative 10, and c is negative 15. So let's put it in the quadratic formula. So we have opposite of b, so b is negative 10, so it's actually going to be positive 10, plus or minus the square root b squared, so negative 10 squared, minus 4 times a times c, which is negative 15. Make sure to always bring those negatives with it. 2 times a. All right, first step. It's the exact same as what I just did up top, or in the last problem. I do negative 10 squared, which is 100. 4 times 5 times negative 15, or negative 4. I always take it as negative 4. 5 times 15. 300. So it'll be plus 300. And 2 times 5 is 10. All right, that's all I do there. My next step is just 100 plus 300. I know it seems meaningless, but if you skip that step, I see a lot of mistakes there. So we look at the square root of 400. Simplify that then. So we have 4 times 100. No prime numbers yet. 10 times 10, you could stop there because we have pairs of 10s, or you could keep going with 5 and 2 and 5 and 2, and you'll get other pairs. So it looks like we have a 2 and a 10, which is 20. So square root of 400 is a perfect square. It's 20. Perfect. So if you knew that right away, good for you. High five. All right. Here, we don't have any more, no more square root. So this is kind of a cool thing. You can actually break it up into 10 plus 20 divided by 10. So 10 plus 20 is 30. Divided by 10 is 3. So one of our answers is 3. And we have 10 minus 20. Don't forget that plus minus. So that's where we're getting the plus, and now with the minus over 10. 10 minus 20 is negative 10 over 10, which is 10 ends up to be negative 1. So yeah, 3 and negative 1 are our solutions. So sometimes you just don't have the square root. And you simplify it down and you just got awesome answers. So this one, you could have actually graphed it as another way to do it, and you would have seen it across the x-axis at 3 and negative 1. It's a great way to check it too. All right, come to class with